Greetings everyone, today I am going to test RTX 5090 on SwarmUI with FLUX models, Stable Diffusion XL, SDXL models, Stable Diffusion 3 model, and also Stable Diffusion 1.5 models. Currently, SwarmUI is not natively supporting RTX 5000 series yet, but don't worry, at the end of the video I will show you installation and download of the models. So as usual, I have added two backends. One of them is RTX 5090 and the other one is RTX 3090 Ti. And I did set the FLUX Dev parameters. The model is selected. 20 steps. I am going to generate 10 images. So let's see its speed with 1 megapixel resolution. Let's generate. Meanwhile generating, let's watch the values of the GPUs. So let's reset and let's also reset this one. Currently I am generating images with FP8 precision. When we go to the server and logs, we will see the speed of the generations and we are seeing the per step speed. Unfortunately, it is lower than what it is because I am recording a video right now. I will stop the video and generate again and show you its optimal speed when there is no recording. And the images are getting generated right now. I have generated few images while the video recording has been turned off, and we can see that it is taking around 10 seconds for generating images on RTX 5090 and 25-26 seconds to generate on RTX 3090 Ti. So the step speed is around 2.2 IT per second and 1.27 seconds per IT. We can see that RTX 5090 is 2.5 times faster at 8-bit precision. Now I'm going to change the precision to 16-bit from here, and I am also going to select the 16-bit precision clip model from here. This is improving quality for sure, and let's see the new speed. Let's generate. This will not fit into VRAM of the RTX 3090 Ti, possibly especially if it is your primary GPU, because your Windows will be also using VRAM. But let's see its speed. It will be doing some offloading probably, so it will be possibly slower. Now both of the GPUs are running. You see this is the watt usages as you are seeing right now. Let's go to the server, debug. So these are the speeds. Now I will turn off video recording to get perfect timing. Alright, few images have been generated and we can see that RTX 5090 is faster in 16-bit precision. It is now 9.55 seconds for per image, and RTX 3090 Ti is taking around 30 seconds for per image. So RTX 5090 is 3 times faster than RTX 3090 Ti. Now I'm going to test FLUX Fill Dev model. Let's edit this image and let's inpaint somewhere of the image, perhaps here, here, and let's say green car light. It is not important. We just want to see how it works. So the model is selected. Init image creativity 1, init image reset to norm 1. And we also need to set the flux guidance scale as 30. And let's generate some images with the FLUX Fill Dev model. Okay, so the generations has been started. Now I will stop video recording and test its maximum performance. Let me also show you the status of the GPU and the usage and the watts. As you are seeing right now, it is almost using the maximum power, and these are the power limits. We can also see the values here, the GPU temperature, hotspot, and everything is displayed on the screen right now. You can just pause the video and check them out if you wish. Alright, the images have been generated. I slightly modified and made it bigger, and we can see that the duration is almost same as the FLUX Dev model with the FLUX Fill model. Now I'm going to test changing prompt speed, because someone asked me to do that to see the difference between changing prompts or not. So for this test, I am going to use FLUX Dev model. I'm going to generate two images. Let's load now. I will stop video recording to see its real impact when we change prompt, how much time it takes, how much difference it makes, to compare it to generating multiple images with the same prompt. Alright, changing prompt added significant amount of duration to the generations from around 9.7, 9.6 second to 13.4, 12.5 second generation. So it increased the image generation duration around 30% whenever you change a prompt. We can see the same behavior on RTX 3090 Ti as well. It is increased to 37 seconds from 30 seconds, 20.9.5 seconds. So changing prompt has such dramatic impact because it is encoding the prompt with the T5 XXL encoder model. Therefore, it is adding a delay whenever you change a prompt. Now I will show you the speed of the generations on SD 3.5 medium model. So I am selecting this model and let's see the generation speeds. Let's generate 10 images. I will set the CFG scale to 7 and the rest is same. I am going to make the test with FP8 first, then I will test with FP16. Let's begin. In the first generation, I will show you the values, then I will turn off the recording and test again. So let's see the values of the GPU. The generations has started. We can see that it is using lesser VRAM because currently we are at the FP8 precision. We can see the CPU usages as well. Let's reset. Okay, memory clock, GPU clock. The GPU clock is just mind-blowing, as you can see right now. Let's see the IT per second while recording a video. Yes, it is just mind-blowing. 4.7 IT per second, as you are seeing on RTX 5090. And RTX 3090 Ti is 2.38 IT per second. All images have been generated with the SD 3.5 medium model. We can see the generations. Now I will turn off video recording and test again. Alright, the generations has been completed. It is taking 3.88 seconds on RTX 5090 and 8.6 seconds on RTX 3090 Ti. Now let's try the generation in 16-bit precision and let's see if there is any difference or not. The 16-bit precision image generations also took same amount of time. I didn't see any significant difference. So since both of them is fitting into the VRAM, there is no issues and there is no difference. I am downloading the large model as well, and now I am going to test large model with the same way. Okay, currently generating images with the SD 3.5 large model, and you can see that both of the GPUs are running with maximum performance. We can see that 100% of usage. They are both fitting into the VRAM. Even at the 16-bit precision, we can see that it is using the entire GPU power, 575 watts and 450 watts. If you want to see the GPU, I already made a tutorial video about it. It will be in the playlist that will be in the link of this video. So I recommend to watch this first video to learn more information about the GPU and how I am using it in my machine. Alright, so 10 images have been generated while I am not recording, and we can see that for Stable Diffusion 3.5 large model, RTX 5090 is performing around 9 seconds for per image, and RTX 3090 Ti is taking around 21 seconds for per image. Another thing is that I am running my RTX 5090 slightly overclocked. You can see plus 1500 memory and plus 300 GPU clock. Now I will repeat the test on SDXL and SD1.5 model. All of the models are tested at 1 megapixel, except I will make the test with SD1.5 with 768 to 768. For SDXL testing, I am going to use SDXL Juggernaut XL version 11, and let's see. Okay, the tests are beginning very quickly. We can see the speed. Wow, the speed is almost real time. This is 20 steps. This is not a lightning model. And real time, you are watching the speed of generation on RTX 1590. It is just mind blowing. Yes, already completed. Let's generate 20 more images. As you are seeing, the value is here. It is just too fast. And yes, the images are just popping up. Let's see the IT per second. Wow. Wow, it is just amazing. 8.8 IT per second. I mean, just mind blowing. So to see the real speed, I will now stop recording and let's see that. Alright, SDXL is taking only 2.2 seconds on RTX 5090 and 5 seconds on RTX 3090 Ti. We are doing 20 steps so far. Let's see the step speeds in the debug menu. Yes. So we see that it is 10.1 IT per second for RTX 5090 on SDXL and 4.2 IT per second on RTX 3090 Ti for SDXL. It is time to test SD 1.5. For SD 1.5, I am going to test SD 1.5 Realistic Vision version 6. I am going to change the resolution to 768 to 768, otherwise it is too big resolution for SD 1.5. And let's see the speed. Okay, yes, even this resolution is sometimes too big, but the speed is just mind-blowing as you are seeing. Yes, you see, they are just popping up, almost instant. Wow, just mind-blowing. Now let me stop the video and see. Alright, the speed is just mind-blowing. We can see that 1.2 seconds for RTX 5090 and 2.2 seconds for RTX 3090 Ti. Let's see the step speed. These speeds are just mind-blowing. And yes, we can see that it is 19 IT per second, almost 10 IT per second. So these are the speeds for SD 1.5 at 768 to 768 resolution. This is just amazing. So I have prepared a table for you to see everything in a single place. I have made some extra testing. Stable Diffusion 1.5 at 512 pixel resolution. So the average image generation takes 1.14 seconds for RTX 3090 Ti and 0.64 seconds for RTX 5090. These are all 20 steps. The step speeds are also calculated based on the average times. So actually they are a little bit faster because it doesn't include VAE decoding. So with the SD 1.5 at 768 pixel resolution, the timing increases average to 2.23 seconds for 3090 Ti and 1.2 seconds for the RTX 5090. You can see that the speed differences are also like this. Especially we see more difference as we go to the more demanding models. For example, SDXL, the RTX 5090 is 2.35 times faster than RTX 3090 Ti. With Stable Diffusion 3 large model, when we run it at FP8 precision, it is 2.42 times faster. When it is 16-bit precision, it is 2.5 times faster. Especially when we run FLUX at 16-bit precision, which is the highest quality, RTX 5090 is 3.08 times faster. Yes, this is a really significant speed difference. We can see that it is taking on average 10.67 seconds to generate one image. The lowest generation is 9.39 seconds, and the highest generation took 20.68 seconds. This is probably not very accurate. I used AI to parse the logs, but it was on average around 9 to 10 seconds, as we have seen. So the relative speeds are probably very accurate. So this is the table. Just pause the video and look carefully if you wish. Now, how you can install SwarmUI and make it compatible with RTX 5090 series. This is the part where I will explain how to install it. For installation, there is a post on this GitHub repository. You can follow this post. However, I have prepared one-click installer as well. The one-click installer is included in our SwarmUI easy, ultra-fast and robust unified downloader. The link will be in the description of the video, and in this post, just download this SwarmUI model downloader version 20 zip file, extract it into any folder you wish. Let's extract into my E drive. And once you extract the content, you will see that there is SwarmUI installation. SwarmUI Windows installer. This will start the official installation. Let me demonstrate you quickly. So it is starting. It is starting to install. It is pretty fast. This is the official installation, as I said. The installation started. You see it is started at this URL. You can also see that it is started here. Then agree. Just actually, let's say customize settings, modern, dark, next, just yourself, ComfyUI local. I am not going to download anything, and yes, I am sure to install. Wait for installation to be completed. Meanwhile, you can also download any models that you want. We have very fast downloader. You see Windows download models.bat file, double click it and run anyway. We have downloading feature for all these models. Just read here. You see FP16 FLUX Dev, FP8 FLUX Dev, FP16 Stable Diffusion 3.5 large, FP8 Scaled Stable Diffusion 3.5 large, T5 XXL FP16 version, FP8 Scaled T5 version, which works better, Stable Diffusion 3.5 medium, FP8 Scaled Stable Diffusion 3.5 medium. If it is scaled, it means that its weights are optimized, so it is in half precision, but it is improved than the half precision. We have the segmentation models. We have text to video model Genmo Mochi 1. This is also still working. We have Flux Redux, Depth, Kenny, FLUX Fill model for inpainting and outpainting. We have the newest better clip large model. In my all experimentation so far, this works better than the default clip large model. We have the very best deterministic upscale models, which I recommend. So you can download all of them. Just type whichever you want to download like this, and it will download all of them with amazing speed. Let me demonstrate you. So the first file is small one. It is slower, then it will become very fast when downloading a bigger file. Yes, it is downloading with 100 megabytes, 200 megabytes per second. So this is depending on your internet speed, of course, but this is optimized to use your entire network speed. 200 megabytes per second, 300 megabytes per second. You can use this downloader to download anything you wish. Okay, let's see our installation. I think it is completed. Yes, the SwarmUI has been loaded. Now what I'm going to do is I will upgrade the ComfyUI backend automatically for you so that it will work with the RTX 5090 series, RTX 50 series. It can be RTX 5080, 5070, 5060. Currently natively it is not supported, so you need to do this. So let's close this. Then double click SwarmUI upgrade torque. This is going to download the pre-made ComfyUI backend into the accurate folder. You see it is downloading with 8 threads, so it is super fast. Then it will delete the older one. Be careful with that, because if you have other extensions, installations, or other stuff, they will be all deleted in the ComfyUI backend, not anywhere else. So you can also make a new fresh installation and install it there. So which folder this is going to delete? This is going to delete the DBL backend, ComfyUI, Python embedded. This is going to delete this folder. You see it deleted it, then it will extract the content and it will not do anything else. So whatever installed inside this Python embedded folder will be deleted and will be replaced with pre-made by ComfyUI developers themselves, and the SwarmUI will start supporting RTX 5000 series. This is all for today. Hopefully I will be making much more AI related and other test videos for RTX 5090. Keep watching, it will be inside the playlist. You see RTX 5090 benchmarks, tests and experiments. So stay subscribed, make a reply and tell me which videos, which AI models you would like to see, and hopefully I will try to make them. See you later. Thank you.